Okay, good evening, students. So we will see today some questions based on vertical motion. Okay, vertical motion. Okay, so in our video lecture, few sessions we have taken where we have divided into case 1, case 2, case 3, case 4. So case 1 is what? Free fall. That is, initial velocity is going to be 0. Case 3 is just throwing down with some initial velocity. So it is not just drop but throwing down. Case 3 was what? Throwing upwards with some initial velocity. And case 4, what we have discussed, if there is a building or something like this, so from here we will be throwing something. So it will be a mix of case 1 and 2, 3, everything will come. And all the physical quantities which is in the upward direction, we take it as positive, and in downward direction, we take it as negative. And in vertical motion, this is what kind of motion? This comes under constant acceleration motion. This comes under constant acceleration motion, this vertical motion. So constant acceleration motion. So we can use which equations? V is equal to u plus at, v square is equal to u square plus 2as, s is equal to ut plus half at square, sn is equal to u plus a into n minus half. All these kinematic equations we can use because we have a constant acceleration here. What is its value? G is equal to 9.8, or we can use it as 10 meter per second square almost in all the questions. Okay, and its direction is going to be in the towards the ground. Generally we take it as negative in almost all the cases. Okay, so this is the fundamental for this. Another important thing which we need to understand is, suppose if something is falling down, then this equation, which one? This equation, if we use, we can find the displacement for 111 seconds. Say for example s1, if it is a free fall, u is equal to 0, s1 is equal to what? U plus g into n minus half. So here what will come? Here negative will come. Okay, here negative will come if it is free fall, where here also, sorry, so all the sign we will put here. Okay, displacement is also negative, u is also negative, this is also negative. So everything is negative, so we can make it as positive. So s1 is equal to, and this is equal to 0. So g into n minus half, which one? Sn. So if we consider s1, this is nothing but 10 into 1 minus half. 1 minus half is half. This is going to be 5 meter. Same way, in the next 1 second, if we consider, already we have seen all these before. So this is going to be how much? 15 meter. Then again, next 1 second, this is going to be, S3 is going to be what? 25 meter. So we know this is nothing but 1 into 5 meter, 3 into 5 meter, 5 into 5 meter. I mean the ratio of displacement S1 is to S2 is to S3. This is going to be what? In the ratio of 1 is to 3 is to 5 is to 7 is to, and so on, odd number ratio. Okay, so this result is from Galileo. Okay, Galileo's statement says, okay, he has given this relation. Okay, this is there in the book also, in CRT also. And if we consider velocity, okay, velocity, that also has some relation like this. Okay, suppose if we are throwing upwards, suppose if it is some initial velocity, then v is equal to u plus at. So v is going to be what? U plus, this is g into 1. So then here this g is going to be negative. G is going to be negative. Okay, but u is here positive. U minus g. So here, suppose if this is the initial velocity, after 1 second, if we consider v1, this is going to be what? U minus g. U minus g. Next velocity, if we consider, this v2 is going to be, suppose if we consider these two positions, and we know that this is going to be, suppose if we consider this v1 as initial velocity, this is again v1 minus g into 1. So everywhere what is happening? v3 is going to be what? Its predecessor, v2 minus 10. That is, the difference in velocity is going to be 10 meter per second. So after each 1 second, if it is going upwards, if it is coming downwards, 10 plus 10 plus 10 plus, each second there will be an addition of 10 meter per second. Is that clear, all of you?
Yes, sir.
Okay. Now we will, these are the fundamentals, and these two relations which I have shown for displacement and velocity, this will be exciting if we use in some problems. Okay. Now take your first problem. Okay. Okay. A player throws a ball upwards with an initial speed of 20 meter per second. What maximum height does the ball rise, and after how long does the ball return to the player's hands? Okay, take g is equal to 10 meter per second square and neglect air resistance. Okay, so you can also do with me. If you are getting the answer, please comment the answer. Okay, so what they are asking, what maximum height does the ball rise? Okay, so we know the formula for maximum height. So maximum height is what? The formula for maximum height is u square by 2g. In the case of maximum height, that is third case, case number 3, we have discussed this. So if we substitute this is going to be 20 square divided by 2 into 10. So this 20 can be cancelled off. Maximum height is going to be 20 meter. Correct or what? Then how long does the ball return to the player's hand? This is nothing but time of flight. T is equal to 2u by g. 2u by g. They have given the initial speed. So 2 into 20 divided by 10. So this can be cancelled off. We will be getting 4 seconds. Okay, so 20 meter and 4 seconds. We are getting the option as option A. Is that clear, all of you? Are you getting?
Yes, sir.
Okay. So see, now just like this method, the previous discussion which we have done in this case. Okay, how this can be, I shall show you how this works here. See, suppose if this is the ball and if it is thrown upwards with a velocity 20 meter per second. Now what they are, already we have found like t is equal to 4 seconds. So after 1 second, the velocity will become what? I told you 10 minus 10 meter per second will happen after 1 second. So here the velocity is going to be 10 meter per second. Again, further, after 1 second, what will happen to the velocity? This velocity will become what? 0 meter per second. From there again it will return back. So when it returns back after 1 second, again the velocity will become 10 meter per second. After 1 second, the velocity will become 20 meter per second. So there is symmetry in vertical motion. We have discussed it in our lecture. Okay, symmetry in the, so same level when it is going up. So here when it is going up, whatever be the velocity here, same thing will be when it returns, when it comes back. So 20 meter per second, if it is thrown, then just before reaching the hand or just before reaching the ground, the velocity is going to be 20 meter per second. So if we add them 1, 2, 3, 4, we are getting what? Time of flight is equal to what? 4 seconds. Okay, so in this way also we can see. Okay, so you can see this one already we have studied how these equations, how we got. Now using this technique, this Galileo's technique, this Galileo's ratio, again still we are able to see what? The velocities. Now see, when it comes from top, when it comes from the maximum height, here the velocity is going to be 0. After 1 second, it would have covered how much distance? 5 meter. In the next 1 second, it would have covered how much? 3 into 5, na? 3 into 5. 3 into 5 means 15 meter. See, we discussed in the 1 second, this is going to be 5 meter. In the next 1 second, this is going to be 15 meter. In the next 1 second, this is going to be 25 meter. That is 1 into 5, 3 into 5, 5 into 5, and so on. It will become 7 into 5, 9 into 5, like that. So if you look here 5 meter, then 15 meter. Downwards, we are getting how much? 20 meter. Obviously, upward motion also going to be 20 meter. So this is what they have asked, what maximum height it will take. So in this method also, we can cross verify things are coming correctly. Is that fine? If you understood, just comment so that I will go to the next problem. If you have any doubt, you can ask in the comment box. Certain difficult problems, this concept will help us a lot. Okay, Blesson. Okay, others, all of you? Shreya.
No doubt, sir.
Okay, fine. So next problem. Okay, a ball is projected vertically up with a velocity of 40 meter per second. Find the maximum height reached and find the height at the end of 2 seconds. Find the velocity at the end of 3 seconds. Okay, so can you solve this? Solve this and comment your answers. Okay, so direct method is what? One method is using the formula. Okay, so first question is regarding maximum height. So maximum height is u square by 2g. So this is going to be 40 square divided by 20. So if we solve it, we will be getting 80 meter as the answer. Okay, now what they are asking is, what is the height at the end of 2 seconds? So suppose if it is thrown upwards, the height after 2 seconds. So we will have to find the displacement. So S is equal to ut plus half at square we will use. So find the height after 2 seconds. So this is equal to initial velocity is 40 into 2 minus half into G is 10 into here 2 square. So this is going to be 80 minus 10, 80 minus 40 into 2. Initial velocity is 40. Okay, into 2. So how much it is coming? 70 meter after 2 seconds. Is that correct? Okay, here this is 20. So 60. Okay, for 80 minus 20, 60. That is the answer for second one. Third one is find the velocity at the end of 3 seconds. So V is equal to U plus 80 can be used. So U is 40 minus 10 into 3. We will be getting what? 10 meter per second. 10 meter per second. So other way, if we see if this is projected with the velocity 40 meter per second, then after 1 second, its velocity will become 30. Again, after 1 second, its velocity will become 20. Then after 1 second, its velocity will become 10. Then after 1 second, its velocity will become 0. So 1, 2, 3, 4. Then when it comes back, again 10, 20, 30. When it reaches here, this will become 40. So this is going to be x, 3x, 5x, 7x. So velocity after 3 seconds. Okay, velocity after 3 seconds is what? 1, 2, 3. Okay, so this is going to be 10. Okay, so that we are getting. Then this is actually, this is 5, this is 15, and this is 25, and this is 35. So we are getting 80, right? This total is 80. Okay, is that clear? Velocity and displacement relation. Okay, so this is using formulae and this is using Galileo's ratio. Any doubt in this? If you have any doubt, please comment. Okay, Blessing, Megavardhini, fine. Okay, so then we'll proceed. Okay, this is the next problem. A ball is projected upwards with an initial velocity of 20 meter per second from the building of height 25 meter. Find the total time of flight. So here in this question, this is a situation. Say, suppose if this is ground, this tower is 25 meter, and from here a ball is projected and it will fall to the ground. So this is projected with an initial velocity 20 meter per second. Okay, find the total time of flight. So now this time, this is not actually 2u by g. Directly we cannot take it as 2u by g. 2u by g was time of ascent plus time of descent. Here time of ascent is different, time of descent is different. So how to do this problem? Using formula, initial velocity is given and the displacement is given, not the distance. What is distance actually? If we diagrammatically, if we see this red color, this is what is distance. And which is displacement? Displacement is this one. The height of the tower is what is the displacement. So this is what is actually the displacement. And all the equations of kinematics, this is applicable only for vectors. Only for vectors. Say this distance, this s is equal to ut plus half at square. All these things will help us to find displacement. So we will use that. S is equal to ut plus half at square. Okay, we know this is 25. Okay, so I am putting this as minus because it is the measurement of displacement is done from top to bottom. Okay, minus 25. U, initial velocity is from in the direction, upward direction. So this is going to be 20, and we do not know t. Okay, this is what we need to find. Minus half into, why minus? Because g is minus, into t square. So I got such an equation. So minus 25 is equal to 20t minus 5t square. Bringing this to one side, 5t square minus 20t minus minus 25 is equal to 0. So cancelling this 5, t square minus 4t minus 5 is equal to 0. So this we can factorize this easily. So we will be getting 10 minus 5 into 10, t minus 5 into t plus 1 is equal to 0. So t is equal to 5 seconds is acceptable. Okay, minus t is equal to minus 1, we need not take. So answer is going to be what? D. Answer is going to be D. Okay, now other way how to do this. Suppose here, if the velocity is 20 meter per second, after 1 second, the velocity is going to be 10 meter per second. Then again, after 1 more second, the velocity will become 0. That is, this is at rest. Then what will happen? This will come down 1 second. Velocity here, this is going to be 0. Here the velocity is 10 meter per second. Here the velocity is 20 meter per second. Then again, what will happen? See, 1 second, 2 second, 3 second, 4 second. So now this is actually x, or this is 5 meter. This one is 3x. And when it reaches the ground, this is going to be what? 5x. That is, if this is 25 meter, this height is already given as 25 meter. So 1 second, again, this will take only 1 second. So 1, 2, 3, 4, 5. So again, T's total time of flight is going to be 5 seconds. So using this ratio method also, we can do this. Okay, is that clear, all of you? Any doubt in this? Anyone? Okay. So remember these two methods. Okay. Remember these two methods using formulae, and at the same time using displacement velocity equation also. Okay. If you have any doubt in vertical motion, you can ask. If everything is clear, then we'll wind up. Okay, then we'll stop the session if it is clear for you.